This is Unit 7.1, Introduction to Quadratic Functions. Our objective today is to identify all the key features, all the attributes of a quadratic function. A quadratic function is called a parabola. We're going to find the y-intercept, the x-intercept, which is the zeros, the vertex, the axis of symmetry, the maximum and minimum. So your goal today is that I can graph a quadratic function, given a vertex and the roots of the function, and you need to be able to identify all those parts. All right, let's start with some basic vocab. A quadratic equation is a function that can be written in standard form, and I've given you the standard form here. And we could write it in regular notation or in function notation. Remember that f of x is the same thing as y. And so we have ax squared plus bx plus c. That's the basic form of a quadratic function. You can see an example of a quadratic function on the right. The equation for the quadratic parent function is y equals x squared. Or we could say f of x equals x squared. Now remember that in linear equations, it was y equal x. When we did transformations of linear equations, we used y equals x, the most basic form out there. But now it's y equal x squared for a quadratic. You know it's a quadratic equation because of the squared. The U-shaped graph of a quadratic function, this little shape right here is called a parabola. The vertex is the maximum or minimum point of a quadratic function. In this one, your vertex is going to be right down here. It's where that curve starts to turn and go the other direction. Okay, in this case, it's the lowest point, so it's going to be a minimum. If it is upside down, pointing downward, and you have almost like a hill, the top of that would be the vertex. The vertex for the quadratic parent function is 0, 0, and you can see it right here. That's the vertex, 0, 0. The axis of symmetry, it's this imaginary vertical line that goes through the vertex and divides the parabola in two. And so, for example, it's going to be right through here. We're going to see this in just a second, but it's going to be a line that goes straight down the middle of this through the vertex and divides it in half. In this case, it'd be the equation x is equal to 0. The points where the parabola crosses or it touches the x-axis is called the x-intercepts. Now, it could cross the x-axis or it could just touch like this one. All right. Now, there are four names we can call this. We can call it the x-intercepts, the zeros. We can call it roots, or we can call it solutions. So anytime you see x-intercepts, zeros, roots, or solutions, they're talking about the points where it crosses the x-axis. The quadratic parent function, in this case, has only one zero, and it is right here. Now, we're going to find a little bit later that you could have more than one zero. You could have 1 0 or 2 zeros or no zeros. And we'll talk about that a little more in detail as the chapter goes on. All right, so this is your vertex right here. We talked about that. This is also, in this case, the 0. It is a minimum. The y-intercept is also that point in this case. And it opens upward. Remember, it can either open upward or it can open downward. It will never open side to side. That would make it not a function. And now the axis of symmetry is the imaginary line that goes through the vertex, down through the center. And you can see it right there at x equals 0. Now, when you look at a table, I'm going to go ahead and put all these on here so you can see. So what happens is your vertex is usually going to be in the middle of your table. And then whenever you go to the right, and the answer is 1, when you go to the left, it will also be 1. I call these sister points. That's not the exact name for that, but you can see that they repeat. And the reason why is because your vertex is solo. It's by itself in the middle. But as you go left 1 and up, you're going to see there's a point there at 1. But then you go right and up, and you also have a point at 1. And so they share those y values. And so you'll start seeing these patterns where you have repeaters as they go out. Okay. In this case, let's just look at one and jump right in. So first thing we want to know is they want to know what is the axis of symmetry in the vertex. Well, the vertex is usually easier to find, and so it's going to be this point right here. And that's going to be the point at -1, -9. -1, -9. Then I want to know the axis of symmetry. The axis of symmetry is always going to be x equals, because it's a line that goes straight up and down through the x-axis. So it's always going to be x equals the x value of the vertex. And so it's going through x equals -1. Remember, it's the line that goes through the x at -1 because it's hitting the vertex at -1 on the x. Is this a vertex a minimum or a maximum point? Well, it's the lowest point, so that's a minimum. Is the parabola concave up or concave down? In other words, is it opening upward or opening downward? Well, look to where your arrows are. Your arrows are pointing up, so it's opening up. Do we have any zeros here? Well, I have a 0 right there. It's crossing at -4. And then I have a 0 right here that's crossing at 2. And so my zeros in this case would be the points -4, 0 and 2, 0. Remember, don't go from the axis of symmetry. You go from the origin. And so from the origin, it's 1, 2. From the origin, it's -1, -2, -3, and -4. The y-intercept in this case, it's going to be right here. And it's where it crosses the y-axis, and that's going to be at the point 0, -8. Okay, so that's all the attributes, all the parts of a quadratic function that you have to memorize and know how to find. So if I give you a graph, you should be able to look on that graph and just know all of these parts. All right, let's see one that concaves down. Say once again, you have a axis, you have a vertex. A vertex is going to be right here, and that's going to be the point 3, 9. Remember, from the origin, I went to the right 3 and up 9. And so the axis of symmetry is always going to be x equals where it goes through on the x, or x equals the x value of the vertex. So it's going to be x is equal to 3. So is this a maximum or minimum? Well, it's the highest point, top of a mountain. It is maximum. Does this parabola concave up or concave down? Well, look at your arrows. Arrows are pointing downward, and so that means it's concave down. Now let's determine the zeros of this function. I know that I have one here. That's going to be at the point 0, 0. So it goes through the origin at 0, 0. And then I have another one here, and that's at the point 6, 0. From the origin, you went to the right 6, up and down none. It's an x-intercept, 6, 0. The y-intercept, remember where it crosses the y-axis, and it looks like it's crossing right here. And so that's going to be the point 0, 0. Okay. Now, you also have to be able to sketch a parabola. And so when you sketch a parabola, you're going to have to be able to do this on, on paper or on like the wipe-off board or something like that. I mean, you can't really do it so much on Desmos because you don't have an equation. You can get a general idea. You can put some of these points on there and get an idea. And I'll show you kind of how to do that in a second, but you're not going to be able to actually do the graph without the equation, and we haven't written the equation yet. And so I'm going to start out by graphing this. I'm going to put my vertex on there, my axis of symmetry on there. It's x equals -3. So I know that this line is going to go through the middle of my parabola. So I'm going to go ahead and sketch that line on there. Then I'm going to put the point -3, 5 on. And so the point -3, 5 is right here. I went to the left 3 and up 5. And that vertex, it's going to be on that axis of symmetry because I know that line goes through the vertex. Now, the vertex is going to have a maximum point. So that tells me which way it's going to curve. It's going to, maximum point, it means it's going to be concaving down. So it's going to be a shape like this, like an upside down U. Of course, it's concaving down. And the other 2 points to help me draw this are the roots, right? The roots are your x-intercepts. And so I know I have a root at -5. And I have another root at 1. And so now you can kind of see the shape of that parabola. One thing to keep in mind, you do not want to draw it like a V. It has a curve, right? A curve. And so it's going to look similar to this. And so this has an axis of symmetry at -3. It goes through the vertex, -3, 5. It has roots at -5 and -1. And it's concave down with a maximum point. That's how you would sketch a parabola. All right, let's look at another one. And so the first thing you see is my axis of symmetry is x equal 2. And so it's going to be right there. And I know the vertex is at 2, -2. And so that's the point right here. So it's going to be 2, -2. It's on the axis of symmetry. The vertex is a minimum point and it concaves up. That means it's going to be a U shape. It's going to be pointing upward. So let's place our roots on there, 1 and 3. 1 and 3. And then we draw our parabola. And so once again, you have an axis of symmetry at x equal 2. Your vertex is 2, -2. It's a minimum point, and you have roots at 1 and 3. All right. And then that is it. That's everything you need to know for this class in this section. And so I need you to go ahead and start your practice and then do your STAR checkout and your ticket out the door. Please log in to tutorials if you need any help. Have a great day.